Today we're gonna be working on another Amazon's interview question. This is Leetcode question number 41. First, missing positive. This question is very hard, meaning if you don't know how to do it, it's gonna be really hard to come up with this solution. They want you to do it in O of n, linear time complexity. What they are saying is like return the first missing positive number starting from 1. So if you see 1 in it, uh, look for 2, look for 3. So we're going to be returning 3 because that's the first positive number missing in here. The algorithm goes like this. Let's talk about this one. You have this number, you have this like the array of integers, right? One thing we know that in ideal cases, if nothing is missing, we're gonna have 1, 2, 3, and 4. In this case, we're gonna be returning as a result 5 because 1 is there, 2 is there, 3 is there, 4 is there. Another observation is that if you have 1, 2, 3, 4, any number bigger than 4, which is this returning 5, right? That can be considered as a flag that 5 or more, any number more than 5 is not of any interest. That is not gonna do any, like that is like out of bound, not interested, that kind of stuff. Any number which is less than or equal to 0, any negative number, any zeros, they are also not of interest. So if this input, which we're going to be working on, has minus 10, has minus 5, has 0 in it, they are all of no interest. They are not going to add to the value. We're just want to have, we can change it to a flag. That is another thing. Okay, so the first thing I'm going to do is going through this array, and instead I'm going to change the array itself, and wherever I see a number which is of no interest, I'm gonna change it to that flag f. So if the n is equal to the length of the array, that is 4, our flag, which we wanna change every number which is not of interest, that's gonna be n plus 1, that is gonna be 5. So this array is gonna become 3, 4, 5, and 1. That is the first step we want to do. Okay, the next step is in this one, if you go through it and you see a number which is of interest, right? You're gonna do is, the first thing you want to do is, let's say we are here, right? And this number is of interest. So that number's index, we're gonna create a new number from its index, and so that number is 3, right? We want to say that if, what would be the number if it is 0 indexed? That number is going to become 2, meaning we're going to subtract 1 from that number to, because the numbers are going to be from 1, not from zeros. So we need to fix that number's value to 0th index. So basically we're going to be subtracting that number. If it is of interest, anything which is 5 is not of interest, we're not going to be dealing with it. If it is of interest, right, if it is not 5, we're going to say that decrement 1 once. so that it becomes a correct value to the 0th index. Okay, so this is gonna become 3. Sorry, this is gonna become 2. Go to 0th 2th index. So this is 0th index. This is 1 index. This is 2 index. Go to that index and then make it negative. Okay, so we're gonna say that making this negative would make it -5, and we're gonna be good over here, right? We're gonna make it -5. Now, right, right. So basically it is -5. Okay, go to the next one. Do the same thing over here. The number is 4 uh, corrected to the 0th index is going to become 3. We are telling you to go to 3 third index 0, 0, 1, 2 and 3 and make it negative. So this is going to make it negative over here. Okay, then do the same over here. You do not need to process if it is 5. This is of no interest. This is of interest. We're gonna take the value here and then take these numbers. They were all absolute values. So this absolute value of that one is going to become 1. To the 0th index, it's going to become 0. So we are telling you go to the 0th one and then make it negative. Okay. Yes. Now, magically what just happened is like we ended up with this -3, 4, -5 and -1, right? Start from here and look for anything which is not negative, and that is this one. You're going to be returning the index +1, which is going to be equal to 2, which is the answer. Let's go back one more time and go through it, what we just did. We said initially that when you have an array, where is that? When you have an array, go through it and make the values which are of no interest equal to n plus 1. So our n is the nums dot length. We are going through all the numbers. If it is less than equal to 0 or if it is greater than n, we're gonna make that value n plus 1. In this case, it's gonna become this one. So we are on line number 18 now. That's what it's gonna become. Then we said go one more time, right? Take the absolute value of a number. If it is greater than n, it is of no interest. Don't do anything with it. So in this case, when the j is gonna be or the I is gonna be equal to 5, that would mean that we are continuing. We don't want to process it. Otherwise, we're gonna be processing it. So if it is of interest, decrement it because we want it to be uh, a 0th index, corrected to the 0th index. Okay, if it is greater than 0, because we don't want it to be making it negative, it is if we already are saying that we have processed it. Okay, so if the number is, if again the numbers number, so it's a loop kind of thing, that when you were here, go to the second index 0, 1 and 2, because we decremented 3 and it became, go to the second index, and if it is not negative, make it negative. That's what we are saying. If it is not negative, make it negative. That's all. So in the end, if you keep doing that, you will end up on line number 31. You will have something like that. All we are saying is process it one more time. Wherever you see anything greater than uh, the value of that element is greater than or equal to 0, return that particular index plus 1. If you go through all of it, right, and you don't find any, in this case 0 1 2, you won't find, actually you will find the third one too, but let's say in this case where we have 1 2 3 4, everything in the end is gonna be negative. So what we are saying is like return 5 in that case, n plus 1. That's all. In terms of the space complexity, in terms of the time complexity, we it is linear. We achieved that. In terms of the space complexity, we are not using any extra space. Though that's all we wanted that's all I wanted to cover in this video. Thanks for watching.